Okay, I'm back. And now, in order to understand why do seismic waves curve as they go through the Earth, we have to go back to our definition of refraction, which was the bending of a wave when it goes from one substance into another. So this time what we're going to do is we're going to assume that inside the Earth you have these different rock layers, and that at first the speed is low, and then the speed is a little bit bigger, and then the speed is bigger still, and then finally down here it's going really fast. So that the deeper you go inside the Earth, the faster the P waves can travel, and the S waves if it's solid. And so let's assume that here is your wave that's going to go into this first layer, and we want to know which way is it going to bend. So it's going to go from a region in which it's got a small speed into a larger speed. And so here comes our car, and it's going like this, and this tire is going to get into this layer first, and it's going to speed up. So that means that if this was the direction that it was going before, now it's going to go something like that. Okay, now when it gets to this layer, we do the exact same thing, and we would find that instead of going in this direction, it's going to bend more like that. And then when it gets to this layer, it's going to bend even more. And can you see that eventually it's going to bend so much, it's going to start going horizontally, and then it's going to start going back up again. So that you have a seismic wave that if it's going in this direction, eventually it's going to start curving back up again. And so that's illustrated in that picture there that's on the left. All right, now how does that help us? Okay, so now what we're going to do is assume on this picture up here that you have an earthquake that is going to occur right here, and it's going to start sending out seismic waves. And as these seismic waves are going through the Earth, they're going to begin to bend. But what they found was that these seismic waves, there was going to be an area over here, and then there's an area over here where it's going to be called the shadow zone. And so that's going to be an area where when this thing sets off its earthquake waves, you don't feel them on any seismic stations over here, and you don't feel any on these seismic stations over here. So what could be causing that? Well, as these waves are traveling through the Earth, they're going to be curving as a result of this phenomenon right here. And when they encounter the outer core of the Earth, their speed all of a sudden changes. So the outer core of the Earth is going to be made of liquid iron and nickel. So that means it's going to stop the S waves flat. So the S waves will not be able to penetrate the core. So they're just going to disappear completely. So that means that all of this right in here, you no matter where you put your seismic station, it's not going to detect any S waves because the S waves cannot penetrate into the core. So now let's talk about what the P waves can do. The P waves can go through a liquid, but you'll notice in the picture that they changed direction when they went into the liquid. Now notice they slowed down. So the P waves slowed down when they went into the liquid. So in this picture they were speeding up, so that meant that they always would bend in this direction. But this time, they're slowing down as they go into the liquid core, and then that means that they're bending in this direction. So look very carefully at what the earthquake waves are doing when they enter into that yellow area. So that's going to be the outer core, which is liquid. And so as they go through the P waves, as they go through the liquid outer core, they'll change direction again when they get to the mantle. They'll speed back up again, and then they're going to bend in this direction the way that they used to. So you can see it's very complicated, but you'll end up with places where these P waves do not appear because of the bending in the outer core. And so by using this technique, we have figured out where the outer core is. Okay, let's take a break. And when we come back, we'll talk about the inner core.